Hi everyone. So our next topic is Y parameters, and before going to Y parameters, I will give one Z parameters equivalent circuit for nonlinear device transistor, right? So Z parameter equivalent circuit for nonlinear device BJT, bipolar junction transistor, right? So generally BJT is nothing but this is the circuit diagram. Sorry, device symbol is like this. Okay, so this is collector, base, emitter. We have two types of transistors, so BJT, NPN type and PNP type. So here N type semiconductor, N means N type semiconductor, P means P type semiconductor. Okay. So you can apply NPN, otherwise PNP. Okay, so just you remember this NP and PNP. Just you can focus on this particular collector base emitter terminal of this particular transistor. So this device is nonlinear device. Okay, if you draw the characteristics between voltage and current, you will get nonlinear curve. Okay, nonlinear device. Based on VI characteristics, we can decide this BJT act as a nonlinear device. But in order to design any circuit diagram, so we have to go for linear characteristics only. Okay, if the circuit will provide a linear characteristics, then only we can implement that particular configuration. Otherwise we cannot, right? So in that context we need to convert this particular device into linear fashion. I have already discussed in the beginning itself. So this conversion, the converted circuit will have only resistances as well as dependent sources, right? So for this particular device, the equivalent circuit is like this. And I already told you, Z parameters can be applicable for only, that means in order to analyze Thevenin's, sorry, not only Thevenin's, we can call it as series networks also. Okay, so in order to analyze for series networks, we have to use Z parameters. That is the efficient one. Okay, so that means we can easily analyze the series network with the help of Z parameters. Not only Z parameters, you can use Y, H, G, A, B, C, D, and inverse transmission matrix also, inverse transmission parameters also, right? But the easiest possibility is Z parameters for series networks. Okay, so this is your current source, plus or minus and plus or minus. Okay, right. So this is your V1 and this is your I1, and this one is Z11 into, so otherwise Z11 resistor, and this is Z12 into I2, and this is Z21 into I1, and this is Z22. So here we have V2 and this one is I2. This is the equivalent circuit diagram of this particular device. Okay, so while converting from, this is linear network, right? If you observe this particular network, okay, so this is resistor, this is also resistor, and this one is dependent source. Why? Because Z12 into I2, right? I2 power 1 here, right? Here also I1 power 1. That means what? These two devices, these two dependent sources are linear dependent sources, right? Linear dependent sources. So because of that linearity, so this entire circuit these resistors also linear elements only, linear passive elements, right? So if you observe this entire network, so all the elements having uh, linear characteristics only, so that this network will act as linear network. This is exact the replacement of this particular nonlinear device. While converting this from nonlinear to linear, so this entire network will act as a linear network, and which provides a linear characteristic. Okay, so after that we can utilize in our applications. After that we can utilize in our applications. For example, if you assume this one as port 1, okay, if you assume this one as port 1 and these two are connected with the ground, right, and this one as a port 2, and port 1 having two variables, so v1 and i1, and port 2 having two variables, v2 and i2. Okay, it's like a two port network, right? If you observe this one, it is like a two port network. So that's why I'm taking Z parameter equivalent circuit for nonlinear device BJT is like this. Okay, if you write the expressions for these two loops, this is loop 1 at port 1 and this is loop 2 at port 2. So if you write the KVL expression for loop 1, what you will get, minus v1 plus z11 into i1 plus z12 into i2 equals to 0. So from this what you will get, v1 equals to z11 i1 plus z12 i2. In the similar way, if you apply the KVL expression for port 2, otherwise loop 2, you will get v2 equals to z21 i1 plus z22 i2. So these are what z parameters of this particular uh, device. Okay, get parameters for this particular device, otherwise this network. Okay, so this is the equivalent circuit. Now you may get a doubt, so whether the symmetry and reciprocity condition applicable for this particular network, that is the question. Okay, so if you observe, already told you, reciprocity can be applicable for only linear and passive elements, linear and passive elements, right? But this circuit, active circuit, right? Why? Because these two things are active elements. Okay, if you observe this entire network, so the dependent sources are act as active elements, so that's why this entire network is active network, which provides linear. Linear is verified. Okay, linear is okay, but in the passive case, this network is not passive. So in that context, reciprocity is not applicable for this particular circuit. That means what? In Z parameters, what is the reciprocity condition? If Z12 equals to Z21, then which follows the reciprocity condition. But even if Z12 equals Z21 also, this will not follows the reciprocity condition. Why? Because the presence of active element in this particular network. But what about symmetry? The symmetry condition is what? If Z11 equals to Z22, then the network is a symmetrical network. But if you observe at port 1, so we have Z11 element and Z12 I2 element. And if you observe from port 2, we have Z22 element and Z21 I1. For example, if you make Z11 equals Z22, if you make Z11 equals Z22, then these two elements are same from both the ports. But what about these two elements? This one having Z12 into I2. If you observe this one, Z21 into I1. Both the elements are different or not? Here we have I2 current, here we have I1 current. In that context, so this will not follows the symmetry condition also, right? That means for this particular network, the symmetry and reciprocity condition is not applicable. Okay, so that is the my observation. Okay, that is my observation from the circuit perspective. Okay, so and the next one, so that means if that particular circuit follows the symmetry condition, the port 1 and port 2 both are having same observation, then only which follows the symmetry condition. For example, if I am taking Z11 equals Z22 and these two are elements are same from both the ports, and if you make Z12 equals Z21 and and I2 equals to I1, Z12 equals to Z21 and I1 equals to I2, in that context both the elements are same from both the ends. from both the ports, then it will act as symmetry condition. When only when Z12 equals Z21, Z11 equals Z22, and I1 equals to I2, then which follows the symmetry condition. Okay, so this is about Z parameter equivalent circuit for nonlinear device BJT. Okay, now we will discuss about Y parameters, and the second one, Y parameters are short circuit admittance parameters. Short circuit admittance parameters. Okay, so this is our circuit standard model, two-port network. Okay, this is our network, and for port to 1, this is your port 1, and this is your port 2, and here we have 1 dash terminal, and here 2 and 2 dash terminal, and here we have variables V1 and I1, and here the variables are V2 and I2. Okay, so in the port 1, V1 comma I1 are the variables, and for port 2, V2 comma I2 are the variables. And when you will apply this particular Y parameters means when you are getting a parallel network, that is the first thing. In order to analyze this parallel network, okay, the best suitable parameters are Y parameters, and parallel network is nothing but the alternate format is what Norton's equivalent circuit, right? Norton's equivalent circuit. Okay, in the previous case, what for Z parameters, that is the best way to analyze the series networks, otherwise Thevenin's equivalent networks. Okay, for when coming to this Y parameters, we can use this Y parameters in a best way for parallel networks, otherwise Norton's equivalent circuits, right? So in the previous case for Z parameters, because of that series configuration, because of series or Thevenin's network, so the voltage variables are dependent variables, right? The voltage variables, why? Because the variable factors are what? Voltage is only for series network, right? The current is a constant. Current is constant. The current is flowing for all series elements same value, right? So because of that, current will not vary. Current is the same factor, but voltages will be varying. That how the voltages will be varying means the voltages depends on that current value, right? So in that context, voltage variables are dependent variables and current variables are independent variables. But this is Y parameters. Already I told you Z parameters are that means Z equals to what? 1 by Y. That means Y equals to 1 by Z. That means both are inverse, right? Z inversely proportional to 1 by Y. So both are inverse in nature. So whatever the things you already consider in Z parameters, those all are reversed in Y parameters case. So in the Z parameters case, I am considering V1, V2 are dependent variables, whereas in the Y parameters, those V1 and V2 are independent variables, right? So why? Because in the Y param, already I told you which is suitable, best suitable for parallel and Norton's equivalent. Parallel means what? Current will be different, but voltage should be same, right? Across the parallel branches, voltage should be same. For example, if you take these are the 4 elements, resistive element. So for if you take the voltage drop here, otherwise voltage source is there. So across these all parallel elements, voltage should be same. Voltage should be same. That means voltage will not vary in this parallel circuit, right? In this parallel circuit, what thing will be differ? That means current. For in order to satisfy this old common same voltage, here the current will be changes, right? I1, I2, and I2. For parallel circuits, current is differ and voltage should be same. And this current value, okay, this current value depends on this voltage, okay. in order to maintain the same voltage, current can be varied, right? In order to maintain the same voltage across these parallel branches, the current will be changed, right? That means this voltage value is, in the previous case, dependent, but here independent. Voltage will not depend any other factor, okay? According to this voltage only, current varying, so that currents are dependent variable, voltages are independent variables. That is the key observation, right? So now I am taking here, so V1 comma V2 are V1 V2 are independent variable. In the previous case, for Z parameters case, V1 V2 are dependent variable, but here V1 V2 are independent variables, and I1 I2 are dependent variables, okay? I1 I2 are dependent variables, okay? So now, so that means the equation involves in I parameters, right? In the previous case part, V1 V2, that means the LHS having voltage variables, that V1 equals what, Z11 into I1 plus Z12 into I2, and Z21 into I1 plus Z22 into I2. These are the equations for Z parameters, right? I already told you exactly inverse of Y parameters. In the left side, we have voltages are variables, but here currents are variables, okay? Why? Because these voltages depends on I1 and I2 current. Here I1 I2 are dependent variables, these V1 V2 are independent variables. That means I1 is a function of I1 is a function of V1 voltage as well as V2 voltage, and in the similar way I2 also a function of V1 as well as V2. So in that context, I1 equals to Y11 into V1 plus Y12 into V2, and that I2 equals to Y21 into V1 plus Y22 into V2. These are the two current equations for Z parameters, okay? This is equation number 1 and this is equation number 2, and admittance into voltage will give the current in that particular branch, right? Admittance into voltage, instead of admittance you can take V1 by Y11 equals to what, 1 by Z11 only, right? Y11 equals to what, 1 by Z11. Now if you take Z11, so voltage by impedance will give the Ohm's law or not? Voltage by impedance, otherwise resistance, will give the Ohm's law. So you can take in this way, otherwise you can take in this way also, okay? So admittance into voltage drop will give the current through that particular branch, right? So here these I1 value depends on V1 value as well as V2 value. That's why we can call it as a dependent variables. And when you observe these V1 and V2s are independent according to this expression, okay? So left side variable should be depends on right side variables, okay? So this is about Y parameters, and these are the equations. Now you can take this expression and you can write the matrix format. Okay, these are our two expressions. So the matrix format for this is, so I1 I2 equals to Y1 Y12 Y21 Y22 into V1 V2. So this is your Y matrix. This is your Y matrix. Okay. Now you can evaluate Y parameters. This Y matrix contain Y parameters Y11, Y12, Y21, Y22. Now you can evaluate Y parameters. So first, in order to find out this Y11, so what you have to do? This is your Y11, right? This is your Y11. This is the first parameter. So how to evaluate this parameter? In order to evaluate this Y11, you need to make V2 equals to 0. If V2 equals 0, then only you can able to find out this Y1, right? If 0, then only you can able to find out y11. This is from first equation, y11 and y21. The similar context, if you make port 1 voltage should be 0, that means v1 equals to 0, you can able to evaluate y12 as well as y22. Okay, that means by making short circuit at port 1 as well as port 2, you can evaluate the y parameters, right? So by making short circuit, that is very, very important. In the previous z parameter case, okay, by making open circuit at port 1 as well as port 2, you will get the z parameters. So that's why we are calling open circuit impedance parameters. But in this case, I already stated this is y parameters, which is also called as short circuit admittance parameters. So z equals to impedance and 1 by y, this y equals to what? Admittance, right? Okay, so by making this short circuit, so we can able to find out the y parameters. That's why we can call it as short circuit admittance parameters, right? That is important. Okay, now, so first we have two cases here. First, by making v2 equals to 0, short circuit at port 2. Okay, at port 2, this is the first condition. The second condition, so v1 equals short circuit at port 1, at port 1. Okay, by making this v2 equals 0, we can able to evaluate two parameters. Those are y11 comma y21. By making this v1 equals 0, we can evaluate y12 comma y22, right? First you can take y11. Okay, so y11 equals to, and y21 equals to, right? uh, Now you can tell me what is y11. I1 by v1. I already told you this one will represents output and this one will represents input to output transmission. That means 1 to 1 is nothing but that is we can consider as driving point admittance. I by v by I is nothing but what? Impedance. But here we have I by v, so that we can call it as admittance, right? Driving point admittance. Driving point admittance. That means I already told you. So whatever the amount of current entering through this particular one terminal, same amount of current coming out from this one dash terminal. Okay, the beginning itself I already told you. So మీకు ఏ కరెంట్ అయితే పోర్ట్ 1 నుంచి ఎంటర్ అవుతుందో అదే కరెంట్ మీకు పోర్ట్ 2 ఆల్సో, whatever the coming entering into this second terminal, and same amount of current coming out through this particular 2 dash terminal. So here we can expect I2 amount of current, right? Same current we will get same amount of current at this 2 dash terminal. Okay, so here, so y11 means first of all y is nothing but admittance. The formula for admittance equals what? Current by voltage, right? So this y11, y is indicating admittance, but where you can get that admittance? At port 1, input at port 1, output also at port 1, means this is which is also called as short circuit input admittance, right? Short circuit input admittance. Why I am taking input admittance means if you are considering port 1 as an input port, we can call it a short circuit input admittance. Otherwise you can use short circuit admittance also, that is also an suitable name, right? And next we can go for y21. So in this case 2 is the output and 1 is nothing but input. The admittance can be transferred from port to 1 to port 1. Already you know what is y admittance. Admittance formula in terms of I by v, right? In general formula, right? Admittance is nothing but what? I by v, but where you can calculate 1 to 2 calculation, right? So output indicate port 2. So this numerator term is nothing but what? Output, and denominator term is nothing but what? Input. So here the output is indicated with port 2. So that numerator is nothing but output. Output term applicable to port 1. So that you can take input variable as port 1 related. So that I am taking v1 here. So that I2 by v1. y21 is nothing but what? I2 by v1. But here this I1 by v1, this y1 value is possible only when v2 equals to 0. So that you have to mention always, right? And this I2 by v1 is applicable only when v2 equals to 0. So, and what is the name for this? I2 by v1, that is admittance only. But what type of admittance this one? This is forward transfer admittance, right? That means we have transferred from 1 to 2, right? We have transferred from 1 to 2, so that's why forward transfer admittance, right? Forward transfer impedance, sorry, admittance, not impedance. Okay, some textbooks they are referred forward executed transferred admittance. That is also correct. Why? Because this entire thing possible with the help of short circuit only. By making short circuit only, we will get these y parameters. So that's why some textbooks they are using forward short circuited transfer admittance. Forward short circuited transfer admittance. Otherwise, in general, you can use transfer admittance. That is also no problem. Why? Because this is 1 to 2 transformation. So that's why I'm using transfer admittance. And same thing you can apply for port 2. That means port 1 also. By making v1 equal 0, you will get y12 and y22. y12 y12 equals to and y22 equals to, right? And this one is our output and this one is our input, and already we know I by v admittance is nothing but here output is related to 1 and input is related to port 2, so that I1 by v2, this is possible only when v1 equals to 0. When coming to y22, and this 2 is output and this 2 is input, and in general formula I by v, and both the variables are related to port 2, so that I will take I2 by v2, and which is possible 2 to port 1, so that we can call it as a reverse transformation. So that a reverse transfer admittance. Some textbooks they are referred a reverse short circuited transfer admittance. Otherwise, in general name that is transfer admittance, whether it is 1 to 2 port or 2 to 1, that is depends on this factor, but we can in general name is transfer admittance. And in the case of this I2 by v2, we can call it as driving point admittance. Okay, driving point admittance. Okay, otherwise you can call it as instead of this driving point admittance, you can call it as a short circuit output admittance. Why? Because we are considering port 2 as output, so that's why we can use this particular name, short circuit output admittance. Okay, this is about y parameters for a given standard 2-port network model. Okay, and now we have to verify the symmetry and reciprocity conditions for this uh, y parameters. The first one is symmetry condition. Symmetry condition for y parameters. So that is in the previous case what z11 equals to z22, that is nothing but z parameter symmetry condition, whereas in the case of this y parameters y11 equals to y22, this is nothing but symmetry condition for y parameters. And the second one is reciprocity condition. Reciprocity condition. So for this y12 equals to y21, this is a reciprocity condition, and the proofs I already told you in z parameters, and the same scenario can be applicable for y parameters also. That is homework for you. Okay, yes, you can follow whatever the steps I have given in z parameter. Same thing you can follow in this y parameter. Not only y parameter, you can follow for remaining parameters also, like h parameters, v G parameters, transmission and inverse transmission parameters also, right? So anyway, I will send the hard copy of this particular two port network parameters. So in that all the derivations and all the things are available. Just you can verify the content. Okay. Okay. And next one, I will take one example. Then you will get more clarity. Wait a second. Right. Investigation. The first problem for a given network. So this is our network. So this is YC, and this is your YA 1 dash and 2 2 dash, right? Okay. So this is your if you look if you observe this particular network, which is a pi type network, right? This is a pi type network. Pi type network, also called as a delta network, right? Nodes we don't single node, right? If you consider these two are one single node, it will form a delta network, right? For example, this is one, this is your impedance, and this is your impedance, and this is your impedance. By connecting these two nodes as single node, the resultant network is like this, which forms a delta network, right? So we can pi type network, also called as delta network also. Okay. And in the previous case, what we are taking T network, right? That we are taking T type network in Z parameters, right? So this T network also called as Y network, otherwise star network. So if you bend these two, if you bend this line into two edges, then it forms the Y network. Okay. So this is also called as star network, right? Star network. Anyway, this is secondary. So our network is what? Pi type network, which is also called as a delta network. Okay. సో మీకు ఈ మోడల్లో ఉంది అని అంటే పై పారామీటర్స్ బ్లైండ్గా అప్లై చేయండి. అంటే ఆ పర్టికులర్ స్టాండర్డ్ మోడల్కి ఆ పారామీటర్స్ అప్లై చేస్తే మీరు ఈజీగా ఎవాల్యుయేట్ చేయొచ్చు. అంటే ఈ పై నెట్వర్క్కి జెడ్ పారామీటర్స్ అప్లై చేయకూడదా అంటే అప్లై చేయొచ్చు, ప్రాబ్లమ్ ఏం లేదు. బట్ ఇట్ విల్ టేక్ మోర్ టైమ్. ఓకే. ఫస్ట్ యూ కెన్ కన్వర్ట్ డెల్టా నెట్వర్క్ టు టీ నెట్వర్క్. ఆఫ్టర్ దట్ యూ కెన్ అప్లై జెడ్ పారామీటర్. దట్ ఈస్ ద ప్రొసీజర్. ఓకే. ఫర్ ఎనీ నెట్వర్క్ యూ కెన్ అప్లై ఎనీ పారామీటర్. దట్ డజంట్ మ్యాటర్. ఓకే. బట్ ఈజీ వేలో మీరు క్యాలిక్యులేట్ చేయాలి అని అంటే పై నెట్వర్క్ ఉంది అని అంటే వెంటనే మీకు గుర్తు రావాల్సిన థింగ్ ఏంటి, వై పారామీటర్స్ అప్లై చేస్తే విత్ ఇన్ ద టైంలో మనకు ఆన్సర్ వచ్చేస్తుంది అనేది ఒక ఐడియా అన్నట్టు. ఓకే. ఓకే. సో నౌ సో ఆల్రెడీ వీ నో ద ప్రొసీజర్. సో ఫస్ట్ వీ కెన్ మేక్ ఇట్ యాజ్ v2 equals to 0. Then you can evaluate y11 and y21. And in the second case, if you make v1 equals to 0, you can evaluate y21, sorry, y12 and y22. So this is the method to evaluate the y parameters. So by making v2 equals to 0, that means for this particular circuit, so this one is v1 and this one is i1 and this one is v2 and this one is i2. Okay. v2 equals 0 means you can make it as short circuit. This one, this just you can connect this 2 and 2 dash terminals with one short circuit, then you will get the v2 equals to 0. Otherwise you can draw again here. Okay. Wait a second, I will draw the circuit here. Okay. So this is yc, ya, yb, and now this is 1 dash 2 and 2 dash, and this one is v1 and this one is i1, and here I am considering short circuit, that is v2 equals to 0, and this is i2 amount of current, and this voltage entire this ya okay, entire this YA element having the voltage drop V1, so that at this node I am considering V1 voltage drop, and here I am considering voltage drop V2. Why? Because across this particular element, the voltage drop should be V2, that V2 value equals 0. That V2 equals 0 is the secondary, but the drop across this particular element is what? V2. The drop across this particular element equals to what? V1, right? So that's why I'm taking this node voltage is V1. In between this voltage drop to this particular element, this is the line, right? So we don't have any other elements present in this line. So that's why I'm taking same voltage drop at this point. Okay. For example, this voltage drop and this particular element, if certain element is there, certain resistance is there, so that you can't take this V1 at this point, right? ఈ అంటే ఈ వోల్టేజ్ డ్రాప్కి ఈ ఎలిమెంట్కి మధ్య నాకు ఎలాంటి ఎలిమెంట్స్ లేదు కాబట్టి వోల్టేజ్ డ్రాప్ అనేది డైరెక్ట్గా ఇక్కడ కన్సిడర్ చేసుకుంటున్నాను, ఈ నోడ్ దగ్గర కన్సిడర్ చేస్తున్నాను. సేమ్ థింగ్ ఇక్కడ మీకు ఈ ఎలిమెంట్కి ఈ లైన్కి మధ్యలో మీకు ఎక్కడా కూడా ఎలిమెంట్స్ అనేది లేదు, వేరే ఎలిమెంట్స్ అనేది లేదు, కాబట్టి సేమ్ వోల్టేజ్ డ్రాప్ ఈ నోడ్ దగ్గర ఎగ్జిస్ట్ అవుతుందని చెప్పేసి దాని మీనింగ్. ఓకే ఓకే రైట్. సో దిస్ ఈజ్ రిలేటెడ్ టు కేస్ 1. ఓకే, దిస్ ఈజ్ యువర్ కేస్ 1, this is your case 2. Okay, and now you can apply KCL at this node and at this node. First by KCL at node 1. Okay, now you can tell me the current I1 is entering to, so that I am taking minus I1 plus, and the second current is leaving from this particular branch. Okay, so we don't have any directions here, so that's why this node voltage is superior. I am considering node 1, so that node 1 voltage is superior than all other voltages present in the network. So that's why current leaving from this node in this particular branch, right? So that's why I am taking here V1 into YA. V1 into that node voltage into YA will gives the current through this particular YA branch, right? And next, if you take this YC branch, okay, this YC branch, so that is we have a potential difference here, so that I am taking V1 minus V2 by ఇంపెడెన్స్ ఉండాలి మీకు ఇక్కడ, కాకపోతే మనకి వైసీ అడ్మిటెన్స్ ఫార్మేట్లో ఉంది కాబట్టి డైరెక్ట్ మీరు వైసీ తీసేసుకోండి, దట్ ఈక్వల్స్ టు 0. బట్ అకార్డింగ్ టు అవర్ అజ్యూమ్షన్ V2 equals to what? 0. So in that context, minus I1 equals to minus I1 plus V1 into YA plus V1 into YC equals to 0, and I1 equals to YA plus YC into V1. Now you will get I1 by V1 equals to YA plus YC. But what is I1 by V1? Y11, that equals to YA plus YC. Okay, this is your first Y parameter. Okay, in the same way you can find out, so you can apply KCL at this particular node. You can apply KCL at this particular node. Okay, so by KCL at node 2. Okay, so what you will get here, we have I2 current is entering into this particular node. Just you can take minus I2 plus, and one current leaving from 2, so that node 2 voltage is superior, right? The node 2 voltage is superior than all other nodes, other voltages present in the network. That's why the current leaving from this is V2 voltage, right? And this is ground node, right? The ground node is nothing but what? 0 voltage. Always current flowing from higher voltage to lower voltage, right? So that's why I'm taking current direction towards downside, right? Now here V2 into YB, right? V2 into YB, and the next one is what? YC current. So this is V2 minus V1 into YC. Okay, V2 minus V1 into YC equals to 0. But according to our, we are in case 1, right? According to case 1, our assumption is what? V2 equals to 0, so that you can substitute V2 equals to 0 here. This is V2, you can substitute 0. This is also V2, you can substitute 0. Now what you will get? Minus I2 plus, sorry, minus V1 into YC equals to 0. Now I2 equals to minus V1 into YC. Okay, but I2 by V1 equals to minus YC. So what is I2 by V1? This equals to what? Y21. Now Y21 equals to minus YC. So this is your second parameter, Y21. Okay. So from case 1 we can able to evaluate Y11, Y21. So Y11 equals to what? YA plus YC. Okay, this is your Y network that equals to Y11, Y12, Y21, Y22. So this is your network. According to this, Y11 equals to what? YA plus YC. Y21 equals to what? Minus YC. You need to evaluate remaining two parameters. Now first you can take case 2. According to case 2, V1 equals 0. Then you can able to find out this Y12 and Y22. First you can draw the circuit diagram again. So by making V1 equals 0, this 1 and 1 dash should be connected. Okay. So in that case, so you will get this is YC and this is YA and this is YB. Okay, and these two are shorted, right? This 1 and 1 dash terminals are shorted, so that you will get V1 equals to 0. This is I1 current, and here we have V2, and this is I2 current. Okay, now across this element we have a voltage drop V2, and in between these two we don't have any other element, so that same voltage can be appeared across this particular node. So that is V2. Same context here also, same thing, that is V1. Okay, now you can take KCL at this node and KCL at this node. So first I am taking this particular node, right? Node 1 by KCL at node 1 by KCL at node 1. So from this node, I1 current is entering. So that I am taking minus I1 plus V1 into YA. In this branch, the current is what? This is 0 volts. This is connected to ground node. This is V1. So always current move towards the down. So that V1 by V1 into YA will gives the current through this particular element. And after that, plus V1 minus V2. That means YC current. The current through this YC branch. That is V1 minus V2 into what? YC, which is equals to 0. According to our assumption, V1 should be 0. So in that, so that we will get minus I1 equals to V2 into YC. So now I1 by V2 equals to minus VC. But already you know what is I1 by V2, that is Y12. Now what you will get? Y12 equals to, wait a second, Y12 equals to minus YC. Okay, this is your first parameter in case 2, and the next you can apply KCL at this particular node 2. So by KCL at node 2, so what you will get? Here I2 current entering, and in this branch we have V2 by V2 into YB current, and when coming to this YC branch, the current through this YC branch equals to what? V2 minus V1 into YC. Okay, so now you can take minus I2 plus V2 into YB plus V2 minus V1 into YC equals to 0. But according to our assumption, V1 equals to 0. Now what you will get? I2 equals to YB plus YC into V2. Now I2 by V2 equals to what? YB plus YC. But I2 by V2 is nothing but Y22. So that what you will get? Y22 equals to YB plus YC. This is your fourth parameter. Now you can fill this particular table. So you will get YB plus YC. This is minus YC. And here you will get yb plus yc. So this is your y parameters for a given pi network, otherwise delta network. Okay. సో సింపుల్ థింగ్, మీకు డెల్టా నెట్వర్క్ కానీ పై నెట్వర్క్ కానీ ఇచ్చారు అని అంటే, సో దానికి డైరెక్ట్ మీరు ఫార్ములా అనేది గుర్తుపెట్టుకోండి. ఓకే, వాట్ ఈస్ దట్ ఫార్ములా? సో y11, y12, y21 and y22. So this is your formula. So y11 equals to what? Ya plus yc. This is your network, right? This is your yc. Okay, this is your ya and this is your yb. The first for this first element you can add these two, so ya plus yc. And for the second and third, for this second and third, so both are same value, that is middle element minus vc for y parameters. Okay, and in the case of this fourth element, you can add these two. Okay, for first element you can add these two, for fourth element you can add these two. So that is yb plus yc. For middle elements you can take this middle value with the negative sign. Okay, this is the logic. Okay, this is you can directly apply only when delta network. Okay, for example, so in the for znet, for z parameters case, if you have t network, okay, otherwise y network. Okay, so this is za and this is zb and this is zc. In that context, z11, z12 and z21 and z22. Okay, so now if you want to find out z11, you can add these two. So what you will get? Z11, sorry, za plus zc. If you want z22, you can add these two. Then what you will get? za plus, sorry, zb plus zc. If you want to find out this middle elements, you can take this middle value, that is zc with positive sign, whereas in the case of y parameters you can take negative sign, but in the case of z parameters you can take positive sign. So this is the shortcut form for z as well as y parameters. టీ నెట్వర్క్కి డైరెక్ట్గా మీరు ఇది అప్లై చేసుకోవచ్చు, వై నెట్వర్క్కి డైరెక్ట్గా మీరు ఇది అప్లై చేసుకోవచ్చు. ఒకవేళ మీకు టీ నెట్వర్క్ ఇచ్చి వై పారామీటర్స్ ఫైండ్ అవుట్ చేయమంటే ఫస్ట్ ఈ టీ నెట్వర్క్ని మీరు వై ఫార్మెట్లోకి కన్వర్ట్ చేసేసి అప్పుడు మీరు ఎవాల్యుయేట్ చేయండి. లేదు అని అంటే y is nothing but 1 by z, otherwise you can take y equals to z inverse. Okay, that means inverse of this particular matrix. For example, you have a t network. For this t network, they are asking about y parameters, right? If I want to find out y parameters for this t network, in that context we have two methods. One thing is what, you can convert this entire network into pi model, then you can apply this formula. Otherwise you can find out the z parameters first, then you can take inverse of this particular z parameter. This is your z matrix, right? This is your z matrix. Okay, so for this z matrix you can able to find out inverse matrix. You can able to find out, if you find out inverse of this z matrix, then you will get the y parameters. For example, you have abcd, right? Network, t network or star network, you will get a b c d, right? Now for same network you need to evaluate y parameter. So in that context, what you have to do, y equals to z inverse. Already you have z parameters, now you can evaluate z inverse. So this is in matrix form. So how you find out the incident matrix for this 2 cross 2? First you can take generally the formula for z inverse matrix equals what, adjoint a by mod e, sorry, adjoint this z. Okay, this is z matrix, right? Adjoint z by mod z will give the inverse of z matrix, right? So how you find out this adjoint z means, already you know about matrix. Okay, for this 2 cross 2 you can interchange these two elements, right? So for adjoint z, first you can interchange this a and d elements, you will get a d a here, and you can assign negative sign for this b and c elements, so you will get minus b minus c and delta z. Okay, delta z equals to what, ad minus bc. This is your delta z. Now you can take that means what you will get d minus b minus c a by mod z, that is ad minus bc. Okay, now you can take 1 by ad minus bc into d minus b minus c. This is the inverse of this particular z matrix, right? Once you find out this, you can indicate with y. This is your y matrix, right? So like that also you can follow, no problem. You have two approaches by converting t to y, t to delta, then you can apply y parameters directly. Otherwise you can find out the z parameters for a given t network. After that you can take the inverse of that matrix, that will give the y parameters. These are the two approaches, right? And now next I will give one problem here. This is second problem. So this is your uh, network, and here we have 1 ohm, 1 ohm and 1 ohm. Determine y parameters. Determine y parameters. Okay. Now, so what is the value of this? What is the value of y matrix for this network? So already you know the given network is in pi model only. Pi model, otherwise delta model. Okay, both are same only. So you can apply direct formula, right? So y11, y12, y21, y22. Right? What you will get? So ya plus yc and minus yc. Middle elements are minus yc and minus yc, and next yb plus yc. Okay, this is the formula, right? Now you can apply, you can indicate first these ya, yb, yc values, then only you can easily write the answer. Okay, this is your ya and this is your yb, and always indicate middle value with the yc, right? So now you can take 1 plus 1 minus 1 minus 1 1 plus 1. That means what you will get? 2 minus 1 minus 1 2. This is your answer, right? This is right. Is this correct? This is absolutely wrong, right? Why? Because here I am providing ohms, but admittance always we can indicate mhos, not ohms, right? Admittance can be measured in terms of why, because y equals to what? 1 by z or not? 1 by ohm, 1 by ohm, what you can represent? Mhos only, right? 1 by resistance. 1 by resistance means conductance, that will indicate the mhos, right? Okay. So now, otherwise you can indicate with ohm inverse. That is also no problem. Okay. Ohm inverse in the sense what? Mhos only, right? So if it is mhos, okay, you can directly add, no problem. But here they are providing ohms, so that you can take inverse of that ohms. What you will get? Instead of 1 ohm, you can take 1 by 1. Here 1 by 1. Here 1 by 1. Okay. Because of 1, there is nothing change. Okay. 1 ఇచ్చాడు కాబట్టి మీకు అక్కడ చేంజ్ అనేది తెలియట్లేదు. ఒకవేళ 2 ఇస్తే, ఫర్ ఎగ్జాంపుల్ వీటన్నిటిని 2 తీసేసుకోండి బెటర్. 2 2 and 2. In that context, what? 1 by 2 mhos. Okay, 1 by 2 mhos. 1 by 2 mhos. Now you can add, what you will get? 1 by 2 plus 1 by 2 and minus 1 by 2 and minus 1 by 2 and 1 by 2 plus 1 by 2. Now what you will get? 1 minus 0.5 minus 0.5 and 1. This is your answer, right? So first you can check units. Units are very very important for this type of networks. Okay, whether they are providing ohms or whether they are providing mhos, these are very very important. Okay, blindly don't add the without checking మీరు చెక్ చేయకుండానే డైరెక్ట్‌గా యాడ్ చేస్తే గనక మీకు ఆప్షన్స్‌లో అవి కూడా ఉంటాయి. ఓకే. స్టూడెంట్స్ ఎక్కడ రాంగ్ చేస్తాడనేది ముందే ఎక్స్‌పెక్ట్ చేసేసి, ఆ ఆప్షన్స్‌ని కూడా మీకు క్వెషన్ పేపర్‌లో ప్రొవైడ్ చేస్తారు. సో, మీరు బ్లైండ్‌గా ఏం చెక్ చేయకుండా డైరెక్ట్ ఫార్ములాలో యాడ్ చేసేస్తే గనక మీకొచ్చిన ఆన్సర్ ఆప్షన్‌లో ఉంటుంది. మీరు టిక్ చేసేస్తారు. గేట్, ఈఎస్ఈ పాయింట్ ఆఫ్ వ్యూలో అయితే దానికి నెగెటివ్ మార్క్ కూడా ఉంటుంది. అంటే మీకు కాన్సెప్ట్ తెలియదని కాదు. కాన్సెప్ట్ తెలుసు. బట్ ప్రాపర్ వెరిఫికేషన్ లేకుండా అంటే ప్రాపర్‌గా క్వెషన్‌ని రీడ్ చేయకుండా ఆన్సర్ అటెంప్ట్ చేస్తున్నారు. దానివల్ల మీరు లూజ్ అవుతున్నారు. మీకు అన్‌నోన్ కాన్సెప్ట్ మీరు కంప్లీట్‌గా వదిలేసేస్తారు డెఫినెట్‌గా. దానివల్ల మీకొచ్చే నష్టం ఏముంది? ఒక కాన్సెప్ట్ మీరు అసలు ఏం చదవకుండా మీరు ఎగ్జామ్‌కెళ్లారు. అలాంటప్పుడు మీరు అసలు క్వెషన్సే అటెంప్ట్ చేయరు. దానివల్ల మీరు సేఫ్ జోన్‌లోనే ఉంటారు. మీరు చదవలేదు కాబట్టి ఆ టాపిక్‌ని దాని పైన వచ్చిన క్వెషన్‌ని మీరు వదిలేస్తారు. ఆ క్లారిటీ మీకుంటుంది. బట్ మీరు కాన్సెప్ట్ నేర్చుకొని కూడా మిస్టేక్ చేయడానికి స్కోప్ ఎక్కడ ప్రాపర్‌గా రీడ్ చేయకపోవడం అనేది ఓకేనా. మీ క్వెషన్ ప్రాపర్‌గా రీడ్ చేయకపోవడం వల్ల ఆ మిస్టేక్ జరగడానికి స్కోప్ ఉంది. అందుకనే అక్కడ ఇచ్చిన క్వెషన్‌ని ప్రాపర్‌గా చదవండి. అండ్ సర్క్యూట్‌లో మెన్షన్ చేసిన యూనిట్స్ వచ్చేసేసి ప్రాపర్‌గా వెరిఫై చేయండి. ఓకే. దాని తర్వాతనే మీరు ఆన్సర్ అనేది స్టార్ట్ చేస్తే బెటర్. ఓకే. దిస్ ఈజ్ అబౌట్ ఫర్ ఎగ్జాంపుల్ ఐ విల్ టేక్ వన్ మోర్ ప్రాబ్లమ్. Then, okay, I will take one T network, right? Third, this is 2 ohms, 2 ohms, and 2 ohms. Okay. So find Y parameters. Find Y parameters. So first you need to convert this entire network into delta network. Okay, that is the conversion of a Y to. You can take this one as 3 better, easy for easy evaluation. This is 3 ohm, right? All are 3 ohms. So now you can convert y to delta. So what is the equation for y to delta conversion? So delta equals to 3y. Okay, already we have a y network. So from that I need to evaluate delta, but delta equals to 3y. So that what you will get? 3 plus 3, 9, 9 ohms. 9. These units are important. Already they are providing ohms. Now you can, while converting also, you can take ohms only. Okay, 9 ohms. But uh, for this network, you need to evaluate Y parameters. While calculating Y parameters, first you can convert this ohms into Mohs model. So 1 by 9 Mohs, and here this one also 1 by 9, right? Now you can take the Y matrix, that is Y11 is nothing but you can add these two. So that means 1 by 9 plus 1 by 9, and this is minus 1 by 9, this is minus 1 by 9, 1 by 9 plus 1 by 9. Okay. So just you can simplify these things, so then you will get the answer. Okay, this is one method. Otherwise, you can go with direct method. That is, first you can evaluate z parameters for this. Okay, what is the z parameters for 3 plus 3, 6, and this is 3. This is 3. 3 plus 3, 6. You can take ohms only. Okay, don't convert this into mohs. Why? Because you are evaluating z parameters, so that you want ohms only. So first you can add these two, and next you can add these two, and the middle elements having 3 3 only. Okay, now you can take the inverse of this particular matrix. Y equals to z inverse. In that case, you can take z inverse is nothing but what? Uh, just you can interchange first you can find out the adjacent matrix. After that you can take the mod of this z. Okay, mod of this z, what you will get? Mod z equals to 36 minus 9. So what you will get? 36 minus 27, right? So this is your mod z value. And if you find out the adjacent matrix, just you can interchange these two. So nothing will be changed, and you can take the negative sign for minus 3 and minus 3. So this is your matrix, and which is you can take this determinant of mod z here, that is 27. Now you will get y equals to z inverse equals to 6 by 27 minus 3 by 27 and minus 3 by 27 and 6 by 27. So what you will get? 3 2s are 3 9s are. Okay, so now you will get 2 by 9. Okay, after that minus 1 by 9, minus 1 by 9, and 2 by 9. So this is your, so in this way also you will get same answer. In this way also you will get, if you calculate this, you will get 2 by 9 only, right? This one also 2 by 9. So both the ways you will get same answer. Okay, we have multiple approaches to find out any particular element. Okay, any particular circle. Okay, so ultimately your answer should be same. Okay, so this is about y parameter. Next we will discuss about uh, h parameter, hybrid parameter. Hybrid in the case z parameters is nothing but that is purely designed for parallel network. Okay, that means with easiest way you can evaluate the parallel series networks in a easiest way with the help of z parameter. Okay, so in the next case, so here z parameters, okay, and y parameters. So this is for series, otherwise we can call it as Thevenin's network. Okay, Thevenin's, and here parallel, or in the case of Norton's also. Okay, parallel, which is also called as Norton's equivalent network. Okay, and with the combination of these two, okay, combination of these two will gives the hybrid model. Hybrid model, that is h parameters. Okay, that is h parameters. Okay, so in this case we have networks in two ways: series plus parallel. Okay, series plus parallel, which is also called Thevenin's plus Norton's. Thevenin's plus Norton's. It's the combination of both the network. Okay, but in our two-port networks we have two ports, right? This is port 1 and this one is port 2, right? Port 1 and port 2. Okay, so this is V1 and this one is I1, V2 and I2, right? This is your network, right? So in the previous Z parameters case, if you take Z parameters and next Y parameters, and in the case of H parameters, okay, okay. Now, so this is port 1 and this one is port 2. So in this port 1, the port 1 having series network, okay, and port 2 also having series network. Then that means in both the ports having series network means the simplest way to find out that particular network with the help of this Z parameter. Okay, నేను చెప్పేది ఇక్కడ ఒకటే, ఎస్పెషల్లీ జెడ్ పారామీటర్స్ అంటే ఓన్లీ సిరీస్ నెట్వర్క్స్ అనేది నా ఇంటెన్షన్ కాదు. ఓకే, జెడ్ పారామీటర్స్ ఈజ్ బెస్ట్ సూటబుల్ అంటున్నాను. ఓకే, టు ఎవాల్యుయేట్ ది సిరీస్ టైప్ ఆఫ్ నెట్వర్క్. ఓకే, ఒకవేళ మీకు సిరీస్ సర్క్యూట్ ఉంది అంటే అవుట్ ఆఫ్ 6 పారామీటర్స్లో, ఓకే, అవుట్ ఆఫ్ 6 పారామీటర్స్లో మీ ఏ పారామీటర్ అయినా యూస్ చేసి మీరు నెట్వర్క్ను అనలైజ్ చేయొచ్చు. ఓకే, ఎస్పెషల్లీ దీన్నే యూస్ చేయాలి అని చెప్పేసి నేను చెప్పట్లేదు. ఓకేనా, నా ఇంటెన్షన్ ఏంటంటే both the ports having series networks means the best suitable way to analyze that particular network is Z parameters అంటుంది. ఓకే, అంటే Z parameters యూస్ చేయడం వల్ల సిరీస్ టైప్ నెట్వర్క్స్ని కన్వీనియంట్గా విత్ ఇన్ ద లెస్ టైంలో మనం అనలైజ్ చేయొచ్చు అనేది నా ఇంటెన్షన్. ఓకే, ఇప్పుడు పోర్ట్ 1 సిరీస్ ఉంది, పోర్ట్ 2 సిరీస్ ఉంది. ఇదే సర్క్యూట్కి మీరు డైరెక్ట్ Y పారామీటర్స్ కూడా అప్లై చేయొచ్చు, డైరెక్ట్ H పారామీటర్స్ కూడా అప్లై చేయొచ్చు, ట్రాన్స్మిషన్ పారామీటర్స్ కూడా అప్లై చేయొచ్చు. అవే ఆ పారామీటర్స్ అప్లై చేసినా సరే మీరు సర్క్యూట్ని అనలైజ్ చేసి ఇండివిజువల్ రెస్పాన్సెస్ అనేది ఫైండ్ అవుట్ చేయొచ్చు. ఓకే, బట్ జెడ్ పారామీటర్ అనేది బెస్ట్ వే, బెస్ట్ సూటబుల్ వే అని చెప్తున్నాను. అంటే ఈజీగా మీరు తక్కువ టైంలో దీన్ని ఎవాల్యుయేట్ చేయొచ్చు అని నా ఇంటెన్షన్, రైట్? ఇన్ ద కేస్ ఆఫ్ Y పారామీటర్స్ బోత్ ద పోర్ట్స్ ఆర్ ప్యారలల్. ఓకే, then you can apply this Y parameters to get the answer within less time. And in the case of H parameters, this is, I already told you, it's a combination of series and parallel. Now, so in the port 1, what type of configuration you can take, and at port 2, what type of configuration you have to consider. That is very, very important. So we have two possibilities, right? So first case I will take series, This is series. I already told you hybrid model is nothing but series and parallel combination. The port to 1, if I am taking series, obviously port 2 should be considered as parallel, right? This is one possibility. And if I am taking a parallel connection at port 1, if I am taking parallel connection at port 1, obviously you can take port 2 as a series. So these are the two possibilities in this hybrid model, right? You can take in this way, otherwise you can take in this way also. Either use parallel series connection, otherwise series parallel connection. So here, if you take series and parallel connection, if you take the series and parallel connection, that is comes under H parameter. Okay, if you take series and parallel configuration, that means port 1 series and port 2 parallel, then it is called as H parameters. If you take port 1 parallel, port 2 series means exactly inverse of this first mode. Inverse of this first mode. Port 1 parallel, port 2 series means that is inverse of this first case, right? So inverse of this hybrid model, inverse of this hybrid model, that is nothing but G parameters. Okay, that is nothing but G parameter. This is inverse hybrid. Okay, inverse hybrid. These are the two models. Okay, this is a combination of series and parallel, that means Thevenin's and Norton's network. Anyway, we will discuss in next session about this G and H parameters. Okay, thank you.